In this tutorial, we're looking at 2023 Paper 2 Question 3, and it's all about coordinate geometry of the line. In the first part of this question, we're given 3 vertices and we're asked to get the area of the triangle. You should recognize that this is what we studied in the line part 4. So to get the area of a triangle, we're going to use the formula 1/2 times the absolute value of x1, y2 minus x2, y1. The only caveat to using this formula is that one of your points has to be the origin. So we need to move one of these points to 0, 0. It doesn't matter which one you move, but the one that I decided to move in this case was I decided to move the point 0, 11 to 0, 0. So just think about what do you have to do to the x coordinate and what do you have to do to the y coordinate. We don't have to do anything. We're not going to change the x coordinate at all. That's why I'm choosing this one. But the y coordinate is 11, and I'd have to subtract 11 from the y coordinate to turn that to 0. So to move this point to 0, 0, you do nothing to the x value, you subtract 11 from the y value. And that just means I have to do exactly the same thing to the other 2 points. So the point 4, 6, I'll leave the x as it is, but 6 minus 11 gives me minus 5. And with the point minus 3, minus 1, again I don't touch the x value, but the y value I subtract 11, so minus 1 minus 11 is minus 12. And now we're going to use these 2 points to sub into this formula and to get the area. Here it doesn't matter which one I label as x1, y1 and which one I label as x2, y2. So I'm just going to do it like this. Let's say this is x1, y1 and this is x2, y2. To get the area of this triangle, I simply need to sub into the formula. The formula is 1/2 times x1 times y2 minus x2 times y1, which in this case looks like this. Now if I simplify this down, I'll simply get 1/2, and 4 by minus 12 is minus 48, minus 3 by minus 5, that's 3 minuses, so it's going to stay negative, and 3 by 5 is 15. And then if we simplify even further, minus 48 minus 15 gives me minus 63, and remember the purpose of the absolute value signs there. The absolute value means that you're going to ignore the negative. If it works out negative, you're just going to ignore it. Basically, the reason it's negative is because I labeled this as x1, y1 rather than labeling this as x1, y1. If you label them the other way around, we'd have a plus 63 right now. Instead, we're just going to ignore the negative and we're going to say that the area is 1/2 times 63, which is the same as 63 over 2 units to be squared. And that's your final answer for part A here. In part B of this question, you're given the point A, which is coordinates minus 1k, and B with coordinates 5l. And you're asked to find the coordinates of the midpoint of this line. So you just sub into your midpoint formula and it works out easy enough. It works out as 2k plus l over 2. In the final part of this question, we're told that the line 3x plus 2y minus 14 is a perpendicular bisector of the line AB. We're asked to use this information to find a value for k and a value for l. If you know that if this is a perpendicular bisector, that tells us 2 things. A bisector cuts something in half, or in other words, it goes through the midpoint. So if this is a perpendicular bisector, it goes through the midpoint of AB. And in the previous part of the question, we've worked out that the midpoint is 2k plus l over 2. So I know that this point lies on this line. So I'm going to sub in the x and y coordinates into the line, and that will give me one equation with 2 unknowns in k and l. Obviously that's impossible to solve on its own, but the other piece of information we have is that it's perpendicular. So what I can do is I can get the slope of this line, then we're going to get the slope of the line of the slope between the points A, B, and I know that the slopes are perpendicular to each other, so that's going to allow me to come up with a second equation in k and l. And then finally, we'll have a simultaneous equation that we can solve. So I've started off with the simpler of the 2. I've subbed in the midpoint into the perpendicular bisector. Everywhere there's an x, I subbed in a 2, and instead of a y, I subbed in k plus l over 2. It works out handy enough because the 2 here and the 2 there cancel out. 3 by 2 is 6, and I just have a minus 14 there. So if you bring your numbers to the right hand side, you end up with k plus l equals 2. So that's the first equation in what will be a simultaneous equation. Now we need to consider the slopes to try and come up with the other simultaneous equation. So now we need to consider the slopes. Let's go back to part B first of all, where we were given the coordinates of A and the coordinates of B. I've used the formula y2 minus y1 over x2 minus x1 to work out that the slope of the line AB is L minus k over 6. Now, if we look at what the information we're given in the question, the perpendicular bisector is 3x plus 2y minus 14 equals 0. The easiest way to get the slope when given the equation of a line is to isolate y, or in other words, to rewrite your line in the form y equals mx plus c. So what I did was I moved all the non-y terms to the right, and then I divided both sides by 2. So this is what the equation looks like when it's in the form y equals mx plus c. And in this form, the coefficient of x, represents the slope. So the slope of the perpendicular bisector is minus 3 over 2. So this is the slope of the line, and this is the perpendicular slope. Remember that the product of perpendicular slopes is minus 1. That if you multiply slopes by each other, if you multiply perpendicular slopes by each other, it should give you minus 1. So I can use that formula, and it's actually a good idea to write it down. The product of perpendicular slopes is minus 1. If I multiply one slope by the other, it'll give me minus 1. And in this case, the slope of AB is L minus k over 6, and the slope of the perpendicular slope is minus 3 over 2. I know that if I multiply those by each other, I get minus 1. So let's just simplify this down. It's easy to multiply fractions by each other. You just multiply top by top and bottom by bottom. Minus 3 by L minus k will give me minus 3L plus 3k. And on the bottom, 6 by 2 will give me 12. And the right hand side is still just a minus 1. In order to get rid of that fraction, I'll multiply both sides by 12, and I'll get minus 3L plus 3k equals minus 12. I can make that a lot simpler by dividing everything by 3, and I can write it as minus L plus k equals minus 4. And that is my second equation. If I now link this up with the equation we got in the first part, it's going to be very easy to find a value for k and a value for L. So it's a really simple simultaneous equation to solve there. When we were dealing with the midpoints, we got k plus L equals 8. When we were dealing with the slopes, we got k minus L equals minus 4. So I don't have to change anything. Plus L minus L is already cancelling each other out. K plus k is 2k, 8 minus 4 is 4. If 2k equals 4, that means that k is equal to 2. What I did then was I decided to sub into the first equation, but instead of a k I subbed in a 2, and you work out that L is equal to 6.